in this video reference for section 5.3, we're going to learn to write linear equations, but we're going to use a brand new format, which is called the point-slope format. So point-slope format is exactly what it sounds like. It allows you to write a linear equation given literally just one point on the graph and with the slope m. So you no longer need the y-intercept. You can just use any point and use its slope and then write the equation. So the format is y minus y1 equals the slope multiplied by x minus x1. So if we look at an example of this, it's not actually too hard. So the first thing we're going to do here says write an equation in point-slope form of the line that passes through 4, -3, and has a slope of 2. So let's label that here everything we need, which is our x1, our y1, and then this is our m. So the first thing we're going to do now is just plug everything right into our format here, here, and here. So do you think if I pause the video, is there someone here that could fill that all in for me and tell me write the equation in point-slope form? So it would be y now minus a -3 would actually be plus 3. So if we keep going here, equals my slope is 2. Then we have parentheses x, and then minus my first x, which is 4. So that's in point-slope form. But the more user-friendly way to write equations is in slope-intercept form. So we're going to, which is y equals mx plus b. So a lot of times when we have point-slope form, it's a good way to start, but we want to eventually go back to the y equals equation. So let's work through this example together to solve and figure out what the y is going to be equal to. So we're going to solve for that y. So the first thing I'm going to do, if we were just simplifying this, is on the right side we can actually distribute here the positive 2. So I'll rewrite this part of the equation, y plus 3 equals, can someone distribute 2 to the inside of my parentheses? 2x minus 8. We're still solving for y, so we need to, how can we get rid of this plus 3? Minus 3 to both sides. Now I'm going to keep it with my constants there. So I'm left with y equals 2x, and then what will be the last part? Minus 11. So we'll also see in later sections that sometimes you want to go from point-slope to standard form, but we'll do that in a different section. So now that you kind of know a little bit about that, there is a way that you can graph equations from point-slope form. It's a little harder because you have to be able to pull out the correct point and then use the slope accordingly. So let's start with the easy part. If this is already in point-slope form, can someone raise your hand and tell me what is the slope? Is it 2, 2/3, or -3? Yeah, so hopefully you said the slope is equal to 2/3. Now we need a coordinate or our point. So we need to think back and figure out what it was my original x1. So if you go back to the format, it's minus x1. So if you go here, can someone tell me what do you think x1, the x coordinate, would be if we look at that part? Yeah, it's just a 3 because it was minus 3. Now the y can be tricky because here it's a minus 1, you're minus y1. So now if you go here, it says, but the equation says plus 2. So raise your hand, what would it have to make this become a plus 2 instead of a minus 2? What was the original y coordinate? Hopefully you said a -2. Okay. because minus and negative. So originally when they did that part of the equation, it really was y minus -2. So this was your y1 in the beginning, but when they write the equation, obviously they just write it as +2, if that makes sense. So now you have everything you need to actually graph your equation. So I'm going to go here and I'm going to find my point on my coordinate here. I'm going to go over 3, down 2, put a dot. And now I can move according to my slope. So raise your hand. How do I move if the slope is 2/3? Yeah, I'm going to go up 2 over 3. And then in the other direction, I'm going to go down 2, left 3, down 2, left 3. And it looks like this. So quickly looking at it, can anyone tell me what this equation would be in slope-intercept form? Yeah, hopefully you said y equals 2/3 x, and then my y-intercept is -4. So that's kind of neat to see. You can see it here in slope-intercept form and here in point-slope form. All right, let's move over to the next page, taking the actual graph and writing the equation in point-slope form. So we need to be able, again, we need either point and we need a slope. So the first thing we need to do is let's try to come up with the slope. So let's see, this starts here at -1, and then it rises to 3. So what's my rise so far? Hopefully you said 4. And then it runs here, so this is my rise over run from -2 to +4 is how much? 6. So my slope here is 4/6, which reduces to 2/3. All right, and the next part, now we need to figure out a point to use. Now really, you can use any point. So I'm just going to use the coordinate. I think this one's simpler because there's no negatives. So I'll use 4, 3. And so let's go over here and write that equation. So let's write the format. So you have y minus y1 equals m times x minus x1. So now if we plug in what we know into this format, you would write, we should probably go back and write this as x1, y1. So now we can know what to do. So it'll be y minus what? 3 equals, what's my m value? 2/3. And then x minus what? 4. Okay. So now let's try the same thing on the other side, but now let's write it with the other point that was given to us. So y minus y1 equals m times x minus x1. All right. So again, this is going to be a little trickier. So if this is our x1, our y1, and our m again hasn't changed. It's still 2/3. Let's take a look at how this will work. So it's going to be y minus -1. How would you write that? +1 equals 2/3 times x. How would you write the rest of the formula? Yeah, hopefully you would say +2. This minus -2. So now we have two different equations for the same line. So we'll end the video here, and then it would be kind of what I want you to do is actually put both of these into slope-intercept form, and at the end, both equations should be the same equation.